What are we doing today, Roy?
Well, this time I'm going to show how to really use the fraction finder to learn to first find the fractions and then use that as the resource for working out the problems. So I would draw first your attention to the package insert. We're on the front page, and this is the part that starts the math lesson. And so that's where I call this a type A fraction, a type B fraction, and a type C fraction. Now I'll set this aside just to explain what those are. In what I've always called the type A fraction, the denominators have nothing to do with each other. 2 does not go into 3, nor does 3 go into 2. So their product 6 would make a perfectly good common denominator. And now is the step to make the equivalent fractions. 2 goes into 6 3 times, so 1 times 3 is 3. 3 goes into 6 2 times, so 1 times 2 is 2. That creates equivalent fractions 3 6 and 2 6. The 6 copies over here, and 3 plus 2 makes 5. The second type of fraction that the student will see in their typical work is a type B fraction, where the denominators do have a relationship. 4 goes into 8. Since 4 goes into 8, you can use 8 automatically as the common denominator. I call that a type B fraction whenever that occurs. So I've gone to the trouble of continuing to make the equivalent fractions. 4 times 2 makes 8, so 1 times 2 makes 2. And the 1/8 is already with the denominator 8, so it doesn't have to change. Now that we have the equivalent fractions with the common denominators, we simply add the numerators. 2 plus 1 makes 3. In this case, we came up with something that did not need to be reduced or changed to a mixed number. The third type of problem is a type C problem. In the type C problem, the denominators do have a relationship. You could use 24 as a common denominator, however, there is a smaller number that is common to both denominators, namely in this case 12. And so since 4 and 6 both go into 12, we'll use that as a common denominator. Now that we know that the common denominator is supposed to be 12, we need to make the numerators for the equivalent fractions. 4 times 3 makes 12, so 1 times 3 makes 3. 6 times 2 makes 12, so 1 times 2 makes 2. Now that we have the equivalent fractions, 3 plus 2 makes 5, and our answer in this case is 5/12. Okay, and so I'm going to work with a student here, and we'll actually solve some problems. And the first one I'll do shall be an egg crate with an egg crate. So I'm going to roll the dice, and what numbers do you see here?
1/2 and 11/12.
Very good. And so I always tell the student to put the simplest fraction first, and so I'll point into the section that says 1/2 sums ECF with ECF, ECF standing for egg crate fractions, and we happen to be on page 1 of the 35-page manual. And then we just kind of look along until we see the half plus the 11/12, and it happens to be the last one here. So now that we've got that zoomed in on, what type of fraction is this, A, B, or C?
B.
It's a B-type fraction because 2 goes into 12. And so that's perfect. Since 2 goes into 12, we use 12 as the common denominator. 2 times 6 makes 12, 1 times 6 makes 6. The 11/12 is already ready, so we don't need to change it anymore to make its equivalent fraction. Now that we have a common denominator, what is 6 plus 11?
17.
Very good. And notice that the 17 is larger than the 12, so this is a good teaching example because we've made an example problem that's now called improper form, the larger numbers on top and the smaller numbers on the bottom. And so how many times does 12 go into 17?
1.
With 5 left over. So making the improper form into the mixed number makes 1 and 5/12. Every single time that that occurs in this entire workbook, problems have always been changed from their improper form to the mixed number. And so that takes care of the egg crate fraction with egg crate fraction. Just to keep demonstrating how to find the fractions in this work set, I'm now going to mix an egg crate fraction with a non-egg crate fraction, and hopefully I'll like the example that comes up. And so that's a good one. We'll focus on this for a few seconds. 2/3 with 1/10. Now 2/3 is clearly the egg crate fraction because of the denominator, and 1/10 is clearly a non-egg crate fraction, also because of the denominator. So I'm going to set those aside, and this time we'll go on to a section of the book that starts on page 12 and goes to page 30. And so once we're in the middle of that book, we're looking for a heading that looks like, kind of like this: sums ECF with NECF, but the first fraction will be 2/3. And so that obviously means I have to turn back a page. And so I go back here, and then there's the 2/3. Now that I have the 2/3 sums ECF egg crate fractions with NECF non-egg crate fractions, I can scroll along until I find the one that's 1/10, and that turns out to be the first one. Okay, now my student's going to answer the question, for thirds and tenths, is this a type A, B, or C?
A.
It's a type A fraction because the 3 and the 10 have nothing in common. 3 does not go into 10, nor does 10 go into 3. We'll have to use their product, 30. And so 3 times 10 makes 30, so 2 times 10 makes 20. The first equivalent fraction is 20/30ths. 10 times 3 makes 30, so 1 times that same multiplier 3 makes 3. So the equivalent fraction for 1/10 with the denominator 30 happens to be 3/30ths. Now that we have the common denominator and the equivalent fractions, we simply add the numerators. So we take the 30 and copy it over here into the answer section, and then add 20 and 3 to make 23. Now, my student's going to answer this question: is that a proper fraction or an improper fraction?
Proper.
Because this top number is smaller than the bottom number, so we don't have to change that one. In this case, we also don't have to reduce it. Okay, so now I'm going to mix one more problem into it. I'm going to take the last 2 dice and add a non-egg crate with a non-egg crate. And so I'll take and I'll roll those. And this one's too easy because the denominators are the same. I want to mix it up a little bit and get a little more variety. And so I've got 3/5 and 3/10. Now, in order to answer this question, since this was non-egg crate with non-egg crate, I go to the back of the book, the last 5 pages, pages 31 to 35. So let me set these aside for a second and get into the last section of the book. And then we're going to either find the 3/5. Yeah, there's the 3/5. Let me set this right here. Okay, so I'll pause for a second to let that get focused on. Now then, we found 3/5 sums NECF with NECF, and if we bring this over just to the right a little bit, you'll see that we found it right here. Is this a type A fraction, or a type B fraction, or a type C fraction?
B.
Good, because 5 goes into 10. And so now that we've established that, we'll use 10 as the common denominator, so you'll quickly notice that that's in both places there. 5 times 2 makes 10, so 3 times 2 makes
6.
very good. And then we don't have to change the second fraction because it already has the target common denominator tenths. So we copy the 10 over to the right, and then 6 plus 3 makes
9.
And so there's your 9/10. And so now the only thing I wish to do with the remainder of time on this little clip here is to just scroll to some of the other pages where we're showing multiplying and dividing fractions. Like, let me pick on this one here. It's titled 1/4 quotients ECF with NECF. Backwards. Backwards just means that when these dice occur, I've got a section of the book devoted to 1/4 divided by 1/10, and since division is not commutative, you get a different answer when you change the order. I also did a section for 1/10 divided by 1/4, and so the division problems always have twice as many problems as the add and subtract. I'm sorry, as the add and multiply. So anyway, here, to make a long story short, we've got the 1/10 divided by the 1/4, and the second fraction is going to flip, and so we have the 1/10 times 4/1. Every single time that canceling can be done in these problems, I've found it and done it. And so 4 does not go into 10, but they have a common divisor 2. 4 divided by 2 is 2. 10 divided by 2 is 5. So 1 times 2 is 2, and 5 times 1 is 5. And the final answer is 2/5. That concludes that video clip.